Right. So viewers, I will be walking you through the concepts of logical reasoning. So, I want you to pay attention. Please like, share, subscribe. What is logical reasoning? Of course, logical reasoning is the act of thinking or reasoning that is based on scientific method. Your reasoning must be based on scientific method. Maybe you're thinking from this deductive perspective or inductive perspective. It must be based on scientific method. So logical reasoning is the act of thinking based on scientific methods. All right. Before we continue, I would like us to look at some of the various connectives that we have in logical reasoning. Connectives in logical reasoning. So we'll look at the symbols of the connectives, look at the meaning and their usage. So let's have a tabular form. All right. The first one I would like you to know is called negation. This is the symbol for negation, and it means not or negation, not. That is, if you want to use it, we have a statement P, call it negation of P. That is the opposite of P. Then the second is disjunction. Disjunction. Oh, sorry. I'm supposed to write this sign. The second is disjunction. Disjunction, or you call it or disjunction, or, and this is denoted by P or Q. That is, if we have two different statements, a statement P and another statement Q. So this junction is written as P or Q, either this or this. Then the next is conjunction. Conjunction. This is and. P and Q. Conjunction of two or more statements, P and Q. Then the next one is implication. Implies, implication. So this one is a conditional connective, means implication, that is P implies Q. So here, for P to imply Q, it means if P, then Q. You can say if P, then Q. P here is called the antecedent, while Q is called the consequent. Q is the consequent. You can write it as if P, then Q. So that is the meaning of implication. Now, the last but not the least that we'll be looking at is by implication. By implication. So we can say by conditional or by implication. This is P implies Q and Q implies P. It means P implies Q and Q implies P. We can equally write it as if and only if. That's biconditional connective, by implication, if and only if. So we are going to be using these connectives when constructing a particular statement using truth table, or when we are to validate an argument. Now, before we continue, let us look at how we are going to construct a truth table. How to construct a truth table. Just simply write truth table. So truth table will be used to represent these various connectives. It shall be used to represent these various connectives: the negation, disjunction, conjunction, implication, and by implication. So the first one is negation. So to construct the truth table for negation, now for negation we have only one statement. P, Q, R, or thereabout, they represent statements. So for negation we have only one statement. If we have a statement, now that statement can either be true or false. If it is a statement, these are the only two options we have, either true or false. So, of course, we know that T represents true. T represents true. Then F represents false. So the truth value of true is T, while the truth value of false is F. So if we have a statement, it can either be true or false. So for the negation of P, if it is true here, that means the negation will be false. If it is false, the negation will be true. It's just like saying Lagos is in Nigeria. The negation is Lagos is not in Nigeria. That's the negation. Say Lagos is in Ghana. Lagos is not in Ghana. Of course, you know that a statement can either be true or false. It will not be both. Of course, I jumped those ones. I believe we understand already that we have a proposition. A proposition is a statement that can either be true or false. Of course, there are some English statements that are not proposition. If we have question, what are you doing? They are not proposition. But if we have something that can, a statement rather, that can either be true or false, we call it proposition. We also have compound proposition, which are connected together using the various connectives we have described below. Now let us look at the truth table for our disjunction. Disjunction. The truth table for disjunction. So for disjunction, we must have two statements, just like we have here. Two propositions, P and Q. So using truth table to represent this, we have so the truth table for disjunction. For disjunction, we have two statements because we have represented the statements with P and Q. We have P and we have Q. So if we have two statements, both of them can be true, true, true. Both, one can be true while the other will be false. The first can be false while the second can be true, and both can be false. So it's very simple and easy to construct. By convention, this should be the normal arrangement. For the first statement, we have true, true, false, false. While for the second statement, we have true, false, true, false. So this is how you construct your truth table by convention generally. But the idea here is for you to represent the various possibilities, or you call it sample space if you want to relate it to probability. So we have true, 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 false, false, true, false, false. Now I'm using disjunction. True or true is always true. True or false will be true. False or true will be true. False or false will be false. Now, this is the idea here. Disjunction, like I told you, is or, which here I would like to liken to plus. Call it plus. Now, if you remember in your logic gate, if we have 1, 1. So let true be 1 and let false be 0. So that if we have true as 1, then here it will be 1 plus 1. It will be true. 1. In logic gate, there is nothing like 2. Then if we have 1 plus 0, 1, 0 plus 1, 1, 0 plus 0 is 0. That is for disjunction. Now the next one is conjunction. Conjunction, that is and. I call it multiplication. And. So the truth table, of course, we still have two statements. Q. So it will be true, true, false, false. This will be true, false, true, false. So P and Q. Now, like I told you, true will represent 1, false represents 0. And if conjunction is times, we have 1 times 1, that is 1. So true and true is true. 1 times 0, that is 0, false. True and false is false. False times false and true will be false. False and false will be false. So the only condition for you to have true is when both are true. Why for disjunction, the only condition for you to have false is when both are false. Both must be true for you to have true. Now the next is implication. Implication implies implication. So we still have two statements, P and Q. So we have the options true, true, false, false. And here we have true, false, true, false. So P implies Q. Now, this is how implication works. I told you that it is if P, then Q. That is the meaning. P implies Q. For instance, if he studies hard, then he will pass. So this is if he studies hard. So P is studying hard. If he studies hard, then he will pass. Will pass is now Q. P is if he studies hard. Now, the first case here is true. He studies hard, then he passed. So it's true. The condition is that if he studies hard, he will pass. He studies hard and he also passed. True. So the final result will be true. That is for implication. Now, he studies hard and he did not pass. True, false. And the condition is that if he studies hard, then he will pass. Now, he studies hard and he did not pass. That is not true. So this is false. It means that it is false because he studies hard and he's supposed to pass, but he did not pass. Now, the next one is he did not study hard and he passed. Now, this is a little bit tricky. He did not study hard, false. Then he passed. So is this one true or false? Of course, it is true. Now, he passed, he did not study hard. Maybe he knows it already. That is why he passed. So he did not study hard, he passed. So the end result will be true. Then the next one, which is false. He did not study hard and he did not pass. So the end result will be true. He did not study hard and he did not pass. So there is no problem with that. The end result is true. So the only condition for us to have false is when the consequent is false and the antecedent is true. Every other cases we have true. So I believe you rewatch so that you understand better. Now let's move to the final one, which is by implication. By implication, we have P, we have the second statement Q. Of course, you can use any letter to represent your statement. So the various options we have are true, false, by standard. Then we have true, false. So for by implication, it is written as P by implication implies Q. So like I told you, this is the same thing as saying if and only if. So this sign means if and only if. That is, P implies Q and Q implies P. That is the meaning. If you understand what we discussed earlier on about implication and what we discussed about and conjunction. So when we have P implies Q and coming back, Q implies P, call it by implication. So from what we discussed earlier on, if we have true for implication, the result is what? True, like we did before. If he studies hard, he will pass. He studies hard and he passed. So it is true. Then we have and. Now coming back, true implies true will still be true. Combining both of them, true and true, of course, it is what? True. So this result here is true. Then the next one is true, false for by implication. For true implies false, of course, we have false. And now coming back, look at our Q. This is our Q. We are moving from Q, statement Q, to P. Q implies P. So we are coming from false to true. False implies true will give us true. Now combining them with and, false and true will be what? False. Of course, you have, I told you before, false is like time. So, and false is like 1 conjunction is like times. True is like 1. False is 0, conjunction is times, and true is 1. So if we have 0 times 1, of course, we have 0, and 0 is false. And the next is false true. So false implies true, of course, it is true. Now coming back from Q to P, that is true implies false, that is false. So if you combine both of them, true and false, 1 times 0 is 0. So we have false. Now the last one is false, false. False implies false, for what we discussed before is true, and false implies false is true. Combining both, we have true and true, and that is true. So for by implication, the only condition for us to have true is when both of them are true or both of them are false. If one fails, if one is false, one is true, the end result will be false. So that is for by implication. Now, before we continue to the next subtopic, of course, I'll be giving you examples. I would like to show you how you can construct truth tables when you have more than 2 statements. If we have more than 2 statements, how will you be able to construct the truth table? So let's say we have 3 statements, P, Q, and the last statement R, especially if you are asked to prove for associativity or distributive property. So for P, by convention, you're going to write true to capture all the different cases. Write true, 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 false, 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 false. For the first statement, that is 4 truth values and 4 false value. So for the next statement, we write true, true, false, false, true, true, false, false. Then the next statement, we have true, false, true, false, true, false, true, false. So if we have more than 2 statements, this is how you construct the truth table. Then you can apply your conditions if you like. If you observe carefully, you see that we have captured all the various cases that we can have. Like we can have 3 of them to be true, we can have 2 to be true, and the last false. You can have the first one true, second one false, the last one true. True, false, false, and all that. So it's just like getting the sample space when we are discussing about probability to get all the possible outcome, your sample space. So that is what we have. All right, let's look at 2 or more examples under this. The first one, we are asked to construct the truth table for, let's say, P and Q and negation. Let's also use De Morgan's law. We have negation of P and negation of Q. So to construct the truth table for this, of course, we know that this will be the same, is logically equivalent to negation of P or Q. Both are the same, but we want to focus on this. That's the question, to construct the truth table for this. So why this is the same thing as, is logically equivalent to negation of P or negation of Q. Alright, now to construct the truth table for this, like I told you earlier on, you need to consider the number of statements we have. Looking at the first question, how many statements or propositions do we have? Yes, you guessed right. We have 2, P and Q. So of course we have to write all the possible truth values for these 2 statements. So that is very simple. If we have two statements, P and Q, the possible truth values are true, true, false, false, true, false, true, false. That is pretty simple. Now, combining the two of them with conjunction, this is conjunction, and is like times. So if we have true and true, of course it will be what? True. Just like saying 1 times 1, that is 1. Then true and false, 1 times 0, it is what? 0, false. Then false and true, 0 times 1, it is what? False. False and false, 0 times 0, it is false. Don't confuse yourself and be thinking this is the same thing as implication. If we have false implies false, remember we said it is true. But in this case, it is not the same. So this is for P and Q. But the question said we should construct the truth table for the negation of this conjunction. So now the negation, remember what we discussed about negation. Negation is opposite, not. So the negation of this will be false. Of course, this is our P and Q. So the negation of this is false. Negation of false is true. Negation of false is true. Negation of false is true. So our final result is this: false, true, true, true. Now, moving on to the second question, the negation of P and negation of Q. So we have two statements also. So let's write out the possible truth value for these two statements. We have P and Q. So for P, like I told you, true, true, false, false. While Q will be true, false, true, false. So if we have P, the negation of P, that's the opposite. We have true here to be false, true here, false, false, true, false, true. And also the negation of Q, we have false, true, false, true. Look at true to be false, false, true, true to be false, false, true. Now combining both of them with the connective and, that's the conjunction, we have P, negation of P, and negation of Q. Negation of P and Q, that's false and false, of course, to be what? False. False and true be false. True and false be false. True and true is true. So this is our end result for negation of P and negation of Q. You can confirm, I told you, this is from De Morgan's law, that this is the same thing as the negation of P or Q. Let's check. Check. We want to check negation of P or Q. Of course, we need to get P or Q first. We have P, Q, true, true, false, false. See, this will be true, false, true, false. So this or this will be true. The only false we have is this. This will be true. Hello? Hi. Okay. So the negation of P or Q, that's the opposite, will be false, 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 true. Because you can see that they are logically equivalent. Oh.